Hello and welcome once again to another lesson. Today we're going to cover learning outcome 6.12 and 6.13. These are on rotational symmetry. Apart from reflective symmetry that you all know, okay, like for example if we have a rectangle, the reflective symmetry, it has two lines of symmetry. This type of symmetry is rotational symmetry. Okay, and basically the rotational symmetry is determined by how many times the shape fits onto itself during a 360-degree turn. It's best if I show you a presentation and you can see several shapes and discuss their rotational symmetry. Here we are. So again, rotational symmetry. So the order of rotational symmetry that an object has is the number of times that it fits onto itself during a full rotation of 360 degrees. This means that if we have a shape, for example this shape, if I turn it, okay, if I turn it from here, I turn it, how many times does it fit onto itself, okay, in a 360 degrees that is full rotation. The number that it fits itself in one revolution, that is called the order of rotational symmetry. Some shapes might have rotational symmetry of 1, others might have 2, others might have order 3, order 4, etc. It depends on the shape, okay? So, for example, this one, you can see that it didn't fit onto itself more than once, so we say that it does not have rotational symmetry, but it has order 1, okay, order 1. Let me do it again for you. As you can see, it did not fit onto itself before it turned out 360 degrees. The second one, this shape over here, okay, this shape. So we'll do that circle over there so that we know where we have started, okay? And as you can see, this shape has 1 and 2, okay? So it has rotational symmetry of order 2, okay? Because it fits onto itself twice in a 360 degree full rotation. Here, this shape, again, we're going to do a circle there, okay, so that we know from where we started, and we start turning the shape. That is the first time that they have fit into itself, second time, and third time, and we have ended from where we have started. So this time, this shape has order 3. It has rotational symmetry of order 3. If we come to the next one, okay, we can notice that this shape has four arms, 4 leaves, okay? So that tells us that the order of rotational symmetry is 4, okay, because they are the same. We have put the circle there so that we know from where we have started. So 1, 2, 3, and 4, that is one full rotation, okay? So that means that this shape has order 4. What about this shape? This shape is a pentagon. The outer shape is a pentagon, and it has some designs in it. We have these triangles and then another pentagon and these black triangles, which are isosceles triangles. So, it has rotational symmetry, and the order is of 5. Since this is a regular pentagon, okay, and it has 5 equal sides, 5 vertices, it has order 5. So it has rotational symmetry of order 5. Let's move on to another shape, this one. We have a 6 pointed figure, okay? So again, we assume that it will have rotational symmetry of order 6, okay? As you can see, here. So 3, 4, 5, and then one full revolution. So order 6. Okay. Now let's take some basic shapes like this equilateral triangle. Remember that we have different types of triangles. Okay. This one is an equilateral triangle, so we put the dot over there, and if we start rotating this triangle, since it is a equilateral triangle, it has rotational symmetry because it fits onto itself, okay, in one whole revolution, and the order is 3 because it fits 3 times onto itself. Okay, so order 3, equilateral triangle. A square, it has all sides equal, so it has, of course, rotational symmetry, and as you can see, it has a rotational symmetry of order 4. Okay, 3 and 4. Okay, so order 4. This pentagon, regular pentagon, if we start from there, we can see that it has rotational symmetry of order 5. Okay, I'm going to just skip that. So order 5. Now we have a hexagon, 6-sided shape. Again, it's a regular hexagon, so all its sides and angles are equal. So when we turn it into in a full rotation, okay, we end up with 6 times that this shape fits into itself. So we say that it has rotational symmetry of order 6. This octagon as well, it is a regular octagon, so by now you must have understood that it has rotational symmetry of order 8, as you can see here. A rectangle. A rectangle is another quadrilateral, but this time with only 2. Okay, order 2. So it has rotational symmetry, but of order 2. This is a parallelogram, okay, another quadrilateral, and you can see that it has order 2 of rotational symmetry, since when we turn it, it fits onto itself twice. Now, the isosceles triangle. Remember that an equilateral triangle had an order 3. Okay, has an order 3 of rotational symmetry. What about isosceles triangle? As you can see, it does not have rotational symmetry. Okay, so we say that it does not have rotational symmetry, but its order is order 1. A scalene, again, like the isosceles triangle, it does not have rotational symmetry, but it has order 1. We say that it has order 1. Okay, this trapezium, as you can see here, it also has no rotational symmetry, so we say that it has order 1. Since in one rotation, it fits onto itself only once, when it comes again where we have started. Okay, another shape, another trapezium as well. Trapeziums don't have rotational symmetry, okay, but they have order 1. The kite, no rotational symmetry, as you can see, but we say that it has order 1. What about a rhombus? So a rhombus has all 4 sides equal as well, okay, opposite angles are equal, and as you can see, it has rotational symmetry of order 2. An oval. So an oval has rotational symmetry of order 2, because as you have seen here, it fits onto itself twice. Now I have several shapes here. Okay, for example, number 1, the six pointed figure. Of course, it has order 6. Okay. Question 2, that circle with 2 of its quarters black and 2 of its quarters white. It has order 2. Okay. this triangle in triangle, question 3, since they are equilateral triangle, it has an order 3. This question 4, it has order 2. Okay, question 5, we have a circle, but we have an arrow in that circle pointed to one side only. So in this case, it has order 1. Okay, order 1. Question 6, we have this sort of three arms. Okay, so this shape will fit into itself 3 times when it's turned in a full rotation. The rectangle in question 7, it has order 2, as we have already seen. Question 8, we have like a pentagon, okay, and those 5 rectangles with circles, so order 5. Question 9, we have a square and a design. The design is uniform, so since the design in the square is uniform, we can say that it has order 4. Question 10, we have another circle, but this time the circle has an uneven pattern, so order 1. Okay. Question 11, we have that snowflake there. It has 6 pointed arms, so that order 6. Question 12, we have this octagon. Okay, so order 8. Now let's continue on our worksheet. Okay, on page 1 you have this exercise. What you should do is that you need to write the order of rotational symmetry. So in this case, as we have seen on the PowerPoint presentation, this one has order 1. Okay, this shape here, if we turn it, okay, it fits twice into itself. So first the circle will be here, okay, and then it will be on that again. So it fits twice. So the order of rotational symmetry is 2. The circle with these 3 rectangles, so it will fit onto itself 3 times. These 4 arms, 4 leaves, okay, so order 4, and this pentagon order 5. Okay. You should continue the whole worksheet. Okay, the 5 pages that you have. As you can see, nothing that complicated. Okay, so the most important thing is this, that the order of rotational symmetry of a shape is determined by how many times the shape fits onto itself during a 360 degrees turn. Okay, during a 1 revolution. So that's all for today. I will see you in the next video. Bye for now.